In this next video, we look at a system that has already been put into reduced form. So all the row operation stuff has been done. They've actually gone a little bit further with these problems and made the coefficients on the diagonal also 1. So we just need to solve these problems. Now, some of them would be ones that are like what we've dealt with, where you'll have an actual variable that you can solve for in the bottom row. This one isn't one of those cases. Here we have the bottom row that's all zeros. That indicates to us that it's a dependent problem. Remember, if you have a row of zeros with some other number in the last spot, that would be no solution. So the first thing we notice is that row of zeros. That tells us, hey, z, the variable we would have been solving for in that row, can be anything it wants. Can be anything it wants to be. So we let z be a real number. And then we go back and we solve for the other two variables, in this case x and y. So when we go back to row 2 now, we know that y plus 7z equals -2. And then we can solve that equation very quickly for y. Right? Just bring the 7z over. Now we get y is -2 minus 7z. Then we go up to the first row. Now sometimes you'll have a y value here. This one happens not to have it, in which case we'd be substituting in what y is equal to. This time we don't have that, so we can just write that out. X minus 2z equals 5. Again, we have no y term in that equation. If we did have a y term, we would replace the y term with this expression, and we'd still have something involving z. We just have a little bit more simplifying that we'd have to do. And here we just again solve for x. So we bring the 2z over, get 2z plus 5. And then once we have all of our variables, we write out the ordered triple in this case. We know what z is, that's our number. And then x is 2z plus 5, and then y is minus 2z minus 2 minus 7z. And so there's our ordered triple, and we've now solved this system. Pick any value for z, and we can start getting numerical values, points in the plane for this particular problem. And so that's how we handle these ones that are already in reduced form. We just take and use what's given to us.